Welcome. This is Mr. O from my satellite office, where every day we have to wear superhero t-shirts. I wanted to explain a little bit about section 7.5 so that you can do your homework problems and we can be caught up even though we had a couple snow days. The idea in 7.5 is that we're going to break a rational expression up into two rational expressions so that we can integrate easier. And the method is the method of partial fractions. And what I want you to do is look through the book and look specifically at the rule on linear factoring. And in that particular is how we're going to solve this first one. This is number 10. We just go through the example and then we'll see if we can do a couple more examples and get a better idea of what's going on in the problem. This problem, dx over x squared minus 6x minus 7, we're going to be able to break this rational expression into two rational expressions. And if you look at the rule at the same time, it might help you to see how I'm going to do this. But if I have 1 over x squared minus 6x minus 7, that will be equal to a over some factor plus b over some factor, and these two factors come from the factors of x squared minus 6x minus 7. So this would be x minus 7 and x plus 1. And so basically we just need to figure out what a is and what b is, and then we can rewrite the integral in this form, and then it shouldn't be too difficult to integrate because these will be linear factors. So how do we figure out a and b? Well, if we multiply both of these by, we can multiply this one, you can think of it as multiplying this one by x plus 1 over x plus 1, and this one by x minus 7 over x minus 7. You'll get this common denominator of this, and the top should equal 1. So if I multiply this one by x plus 1, we get a times x plus 1 plus b times x minus 7. And so that would be my numerator over here. And what should that equal? It should equal 1. And so you assign values to x, because this should work for any x value. So if I make x equal to negative 1, this whole thing drops out and I can figure out what b is. If I make x equal 7, this whole thing would drop out and I can find out what a is. So I say if x equals negative 1, then you put a negative 1 in there, that would be negative 8. So we'd say b times negative 8 equals 1 from here. And so b equals a negative 1/8. If x equals 7, then if x equals 7, this one drops out and we get 1 equals a times 7 plus 1. So we get 1 equals a times 8, and a equals 1/8. So we could rewrite our integral using these two fractions now as opposed to one fraction, one rational expression. So we get the integral of a over x plus 7, and a was 1/8. So we could say, we can move the 1/8 out here, and that's a, so it'd just be 1 over x minus 7 dx. And then b was a negative number, so we're actually going to put minus 1/8, and then the integral. And because we put the 1/8, the b, we put it out front, and we just have 1 over x plus 1 dx. And we can integrate, and both of these would be natural log. And so we would have 1/8 natural log x plus 7, x minus 7, minus 1/8 natural log x plus 1. And because it's minus, you could put 1 over the other. So your answer for the problem will be 1/8 natural log x minus 7 over x plus 1 plus c. And that is number 10. Very similar to number 9 in your homework. Welcome back. this is number 16 from your textbook, and it's the integral of x squared plus 1 over x minus 1. So for information on this, look back in the chapter. They talk about integrating improper rational functions. Improper just means that the degree on the top is higher than the degree on the bottom. And so to integrate this, you could use long division or synthetic division, and you can figure out how to split these into different parts. And when you split it into different parts, then you can integrate a lot easier. So if I was going to use synthetic division, I could say, well, I'll put a 1, I get a 0 for the x, 1 for this, 1, add down 1, a remainder of 2. So if we look at the synthetic division, we divide x squared plus 1 divided by x minus 1, we get x plus 1 with a remainder of 2 over x minus 1. And when we set this up, we get this. When we divide it out, we get x plus 1 plus 2 over x minus 1. That's your remainder, and your denominator there is x minus 1.
Can I read a book when I read?
Yeah, you can read a book. So we could rewrite the integral. The integral of x dx plus the integral of 1 dx plus the integral of 2 over x minus 1 dx.
Dada?
Yes, Jonas?
Do you know how to read it?
Do I know how to? Yes.
And do you know how to read other books?
Yes, I do. Thank you for asking. Okay, moving on, bud. We have x here. We're going to integrate. This goes up to the second power divided by 2. So the final answer for this one is 1 over 2x squared. It's going to be plus x. And then here, we bring the 2 out, and it'll just be natural log. So plus, and I'm going to run out of space, 2 natural log absolute value x minus 1.
How do you do your camera stuff?
Don't forget your
How do you do?
Okay, last one. This is question number 22. We got x to the 5th minus 4x to the 3rd plus 1 over x to the 3rd minus 4x. The thing you want to do is you're going to want to do long division here. Long division of polynomials. And when you do that, you're going to end up with three different, you're going to end up with, I already took the liberty of doing the long division for you. So what you get is, you get x squared plus 1 over multiplied by x squared.
Are you taking pictures for us? What? What?
And then multiplying by x
Yes?
squared. Yes. You get 1 over x to the 3rd minus 4x dx. So I'll leave it to you to do the long division, but this is what you end up with. Now, integrating x squared dx is not a problem. But this one here, we got x to the 3rd minus 4x, and we can break this and use the partial fraction. So when you get 1, and this has got 3 linear factors. The 3 linear factors would be, so we would have 1 over x to the 3rd minus 4x. We have a over x plus b over x plus 2 plus c over